In this lesson, we'll learn how we can start to set up rigid body dynamics inside of RealFlow. Okay, so in this scene, we have our brick wall that we have in here. And again, picking up where we left off from our previous lesson, we have these individual bricks that make up this wall. Now, what I'd like to do is take this wall and essentially start to break it down by throwing this little sphere primitive at it. Now, first thing I want to do before we actually get into this is I'd like to disable RealFlow's display of all the different objects of our scene. So right now you see each and every little brick that we have listed in here, things like the number of vertices, the number of faces, the X, Y, and Z position. Really, I don't need to know all of that for everything. So what I like to do is just go into my preferences, and let's go into our display area. And instead of having RealFlow display all nodes, which is the default, we can maybe just have it display selected nodes. Press OK, and there we go. Now it'll actually only display whatever we have selected in here. There we are, much better. So the first thing we need to do is start to take our objects and define whether or not they are going to be rigid body objects. So let's start by just selecting all of our different bricks here. This will probably be just as simple as coming in and just shift selecting all of these. Now with all of these selected, what we need to do is go up to Dynamics, and right now it's set to No. So what we need to do instead is set each one of these bricks to be an active rigid body. So with this being an active rigid body, that means it can actually start to accept collisions, it can actually start to move based on those collisions. We also want to take this sphere, and we want it to be an active rigid body as well. So set that to be an active rigid body. Now, if I press the A key on my keyboard, you'll notice that really nothing happens at this point. That's because even when situations where we have no particles, but we do have something like an active rigid body that we want to use, we still need to rely on some daemons, for example, gravity, to actually start to pull some of these down. So if I drop in gravity, you should see there's my little gravity node down there. Now, if I press the A key on my keyboard, you can see that gravity is pulling these objects down, but it's really pulling them right through the floor. So we need to actually make this floor stop these guys from falling down here. So with this floor, what we can do is pull this down, and we can set this to be a passive rigid body. Now with this floor being a passive rigid body, that means it will start to interact with objects that are being pulled down by gravity, things like that, but this floor itself will not be pulled down by gravity. It's really just more of a collision object. Now if you look closely, you can see that my brick wall is already sort of halfway poking through this floor, so it's probably a good idea to come in and grab my floor and maybe pull that down just a very, very small amount, just so we can make sure there's no interpenetration here. And now, if I press the A key on my keyboard, you can see that these objects will now start to fall down, and they should now start to interact with this floor as well as each other. Now, really, this is not exactly what I want. I don't want these things to just fall. I'd really like this ball to be thrown at the wall. So let's go ahead and grab this sphere. Let's scroll down, and with this being set to an active rigid body, we now have this little rigid body tab that can be opened up on that piece of geometry. Now, within this, we actually have this velocity, so we can actually set some kind of an initial direction for either the X, Y, or Z axis. Now, if we look at my axis indicators down in the corner, you can see that we want this ball to move basically in the negative Z axis. So let's give this a negative Z direction of maybe something like 10. Actually, I want to make sure that's set to negative 10 to make sure it moves along the negative Z axis. Go ahead and press A on my keyboard, and now you can see this sphere has some forward direction. But really, you can see it really doesn't do much to do any kind of damage to that wall. It just sort of strikes a wall and then starts to roll off. Now, if I could come in here and continue to increase that velocity to maybe something like negative 30, now you can see it's coming in here with a little bit more force, but it's still not enough to actually begin destroying that wall. So normally within RealFlow, if we have an object that is set to be an active rigid body, the actual mass of that object is determined automatically by its size. So the larger an object is scaled up or sized up, the more massive that object will be. Now, that may not always be something that we want, because we may want to have something that is relatively small, like a cannonball, but still very, very massive. So if we want, we can come in here and just manually define a mass. So let's say instead of a mass of 500, let's set it up to something much higher. Let's say maybe 3,000. So that way it should now be much more dense compared to these bricks, which if you look at the bricks, these are averaging a density of around 2,000. So these bricks are obviously much, much bigger than this sphere, which, as far as RealFlow is concerned, means they should be more massive. Now you can see by giving the sphere more mass, you can basically give it a lot more punch. So if I were to come in and reset that, and again, maybe increase my mass even higher, maybe 5,000. Here we are, and resimulate. Now you can see it's transferring now a lot of energy into those bricks. Now they're actually starting to almost kind of explode out of here. So we can continue to increase that mass, or maybe even increase the size to go ahead and have a similar effect. So let's try something just a little bit larger, maybe 1.3 or 1.5. There we are. We'll start with something like that. And again, maybe take my mass and start to dial that up. Press A to resimulate. There we go. That's starting to look a little bit better. So really, as I mentioned, it's really just kind of a matter of coming in here and tweaking some of these values, maybe not always having something that is 100% physically accurate, but artistically, it's giving you the look that you want. So, again, continuing to increase this mass, you can see transfers more and more energy into these bricks. Now, when it comes to actually working with these bricks and these objects and the ways that they interact with each other and the surrounding areas, we actually do have some control over that. Now, this might be a little bit easier to see if I were to actually take my sphere here. Whoops, let's, instead of 20, let's go 2 by 2 by 2. And now I'm probably going to have to take this mass down. What I'm trying to do is get these bricks to just kind of fall out and kind of explode with a little bit more force. Now you notice that some of these bricks back here, as they start to collide and interact with the floor, that they are really bouncing along quite a bit and actually doing quite a bit of sliding in here. Now we do have some control over that as far as the actual interaction between these objects. So if I were to take something like this floor and scroll down, look for its rigid body tab, we have things like the object friction as well as the elasticity. So friction, really just like the name suggests, that's going to be the amount of resistance that an object is going to face as it starts to slide along this object. So with this being set to something really, really low, like 0.01, that's almost going to be like a glass surface or something really, really smooth. If we wanted this to be something more like asphalt or concrete, this object friction is going to need to be much, much higher. The highest value we can go with this is 1. So 1 would be absolutely no ability to have any kind of lack of resistance. So with this object friction now set up much higher, we should now see a much lower tendency for these bricks to actually slide along the surface. They're probably going to maybe still do a little bit of bouncing, but as far as the actual sliding of these objects, you can see there's really not a whole lot of this sliding happening here anymore. You can see they'll maybe slide for a little bit, but then they come to a rest pretty quickly. Now below this, we also have the elasticity. Now the elasticity is the tendency for this floor to actually transfer energy back into the objects that bounce off of it. So if we find that maybe our bricks are bouncing a little bit more than we like, we could start to take this elasticity and either raise that or lower that if we want to get more bounce or less bounce. So again, if we wanted these to maybe have a much lower amount of bounciness to it, we could take this elasticity and really, really drop this down so that as these bricks actually start to collide with the floor, they really shouldn't do any bouncing at all. They should pretty much strike the surface, and then with that very low elasticity, it should absorb almost all of that energy. So you can see, again, looking at it from the side, these bricks do very, very little bouncing, so very little energy is transferred back into those. However, if we were to take the elasticity up to an even higher value, again, the highest value we can go is a value of 1. So if we were to set that up to something like 0.8, we should now see a much higher tendency for that energy to be transferred back, which should result in a much greater amount of bounciness with these bricks. And you can see that's exactly what we're getting here. So if I were to pull in maybe a little bit tighter here, we should now see where these bricks are bouncing much more substantially than what they were before. Okay, so I'll just press Control A to reset my simulation. So anytime we have objects in our scene, if we have things like rushing water or flooding water, we can have this particles or these fluids actually interact with these active rigid bodies as well. So these active rigid bodies are not necessarily limited to only being able to interact between two different pieces of geometry. So this becomes, again, a really nice way of being able to import geometry, set that up, and either have geometry affect each other or have geometry affected by things like your fluid particles and things like that.